Hello friends, this video on organic chemistry basic part 21 is brought to you by examfear.com. No more fear from exam. Hello friend, this video on organic chemistry basic part 22 is brought to you by examfear.com. No more fear from exam. Now let's talk about electrophiles. The next type of attacking reagents was electrophile. So as the name suggests, electrophile, this is electron and phile means love. So this guy loves electron. If you see, this guy loves electron. The only thing in his mind is electron. This guy loves electron. So electron says, I have enough electrons, right? I have enough negative charge. If you can take some electron from me, you can come near me, right? Because I have enough electron. So these guys are electron accepting group. This is electron accepting group. Correct? So we'll see the definition. So if you see, electrophiles are reagent attracted to electrons and they accept electron pair. Correct? And since they accept electron pair, they are called Lewis acid. And most of the electrophiles are positive charge. Most, but some of them are partial positive charge or it can be a neutral also. But the one which is neutral should have incomplete octet. For example, BH3, BF3, this guy, BH3, they have incomplete octet. For example, if you see BH3, right? So bromine has 1, 2, 3, 4, 5, 6 electrons. It needs 2 more electrons to be complete. So this is electron deficient compound. Correct? So they are having scarcity of electrons. So this is also one electrophile. Correct? So most of the electrophile are positive charge, but some are neutral also, but the one which are neutral should be electron deficient. Correct? For example, H plus if you see is a good electrophile. In fact, chlorine you saw Cl minus, here we have Cl plus, Br plus. These guys are all my Al, Cl3, SO3, they are all good electrophile. We will see one reaction. For example, I have ethane actually in this case, so I have my bromine coming here. So bromine will break into Br plus and Br minus. Here I am talking about the Br plus first, right? Because Br plus, this is the one which will attack, right? Because it's electrophile talking about Br plus will attack. This will break in this fashion, it will become negative. This will become, break in this fashion, this is negative charge, this is positive charge. And on these, the bromine will get attached. On the next, the other bromine will get attached. But this guy is my electrophile here. The next can be this guy. So if you see, this is my benzene in this NO2 plus. If I'm attacking, this is my electrophile. This will attack and this will kick out hydrogen from here and this will form this. H plus will be out. Correct? This guy is out. So this is also one example of my reaction where electrophile is involved. If you're not understanding the reaction, just hold on for some time where we will discuss the types of reactions. Just understand that in this case the electrophile is involved. This here electrophile is involved. Here also electrophiles are involved. Both are my electrophile. Now as we discuss the strength of nucleophiles, we should also discuss the strength of electrophiles because there are so many electrophiles, which one is strong, which is weak, we should know that. So there is only one rule here, mostly the charge. The greater positive charge implies better nucleophiles. So if you see here, these guys, right, charge density I'm talking about. Same charge, less mass, stronger nucleophile. Same charge, more mass, little weak nucleophile. More mass, space, almost same charge, weak nucleophile. So greater charge density implies better nucleophile. So if you see, we talk about the stability also. This guy, since it is a weak nucleophile, since it is a weak electrophile, it is stable also. Weak electrophile, this is stable, more stable. So this guy is more stable and this guy is most reactive, right? This guy is most reactive and best electrophile among all these. Correct? We'll also discuss that due to inductive effect also these guys become stable, but since we have not covered a topic, hold on for that. But this becomes more stable because of inductive effect also, right? So more positive charge density implies better electrophile. The next type of attacking reagent was the free radicals, and they are generally neutral. These are the neutral species and they have unpaired electrons. If you see, each of these has only one electron. For example, chlorine, bromine, OR, R, CS, each of these has only one electron. And we'll discuss why sometimes you get one electron, sometimes you get Cl minus, sometimes you get Cl plus, sometimes you get C dot. We'll discuss this when we talk about the bond cleavage. We'll talk about the different kinds of bond cleavage, and then we'll discuss why we get these three different type of species. But since we have to talk about free radicals, let's see the chlorine bond breakage now. So if the chlorine bond is broken, if you see this bond comprised of two electrons, right? So one bond means two electrons, and each of the chlorine gets the electron, its electron. So you get two free radicals, right? So two chlorine radicals. This is like, see, chlorine if you see has 7 electrons, right? So to form a bond, what it does with other chlorine, it forms a covalent bond where these electrons are shared, and this forms a bond. Now when it breaks, it may happen that both the electron goes to this chlorine, right? Then in that case it will have a negative charge and this will have a positive charge. Or it may happen that both gets each electron each. So in that case it forms a free radical. We'll discuss more about this. So in this case the chlorine is, and this happens mostly in presence of light and heat. Chlorine breaks into chlorine radicals. So if you see the reaction here, I have methane, the chlorine reacts, this is a nucleophile, and this will replace a hydrogen and you get HCl. We'll talk about this reaction. Correct? So just focus on this, from this to this, because this is the intermediate step. This is the final product. You have methane reacts with Cl, free radical, you get CH3Cl and this, sorry, H. Yeah, H will be out actually, and H will react with again Cl to get HCl. This is how it happened. In this case, H came out and H again reacted with the free Cl radical here in the solution to get HCl. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.